Assalamualaikum warahmatullahi wabarakatuh, and hi everybody. Now I will talk about Fourier series using trigonometric form for odd and even functions. Before that, please ensure that you are now really understand about odd and even functions so that you can follow this lecture very well. Okay, now let us recall the general formula of Fourier series expansion that we have learned before, where we can see that once we have a periodic function of ft equals to ft plus period, where this period t or capital T equals to 2 pi over omega, then we can see that the ft can be expanded as Fourier series expansion equals to half a naught plus the summation of a naught an cos n omega t plus summation of bn sin n omega t, as what we can see from this series 1. And from here we know that the a0 or a naught and an can be defined from this equation, whereas the bn can be defined from this equation. Okay, now look carefully the following formula dedicated for even and odd periodic functions. First, if we consider an even function when the ft equals to f minus t with period t, what we can see that the Fourier series expansion can be defined as ft equals to half a naught plus summation of an cos n omega t. In this case, we need only to find the a naught and an, where it can be defined as this one. And what you can see here, the an for this formula is different with the one defined for the general formula of Fourier series expansion. And what we can also see here, that the Fourier series expansion of even function only contains cosine terms. Okay, now let's look at the Fourier series expansion of odd function when the ft is defined as minus f minus t with period t. Here, the ft is defined as a summation of bn sin n omega t, where the bn can be defined as this formula. And what we can see from here, the bn here is defined differently as what we can see from the previous bn for the general Fourier series expansion. And the Fourier series expansion of odd function only contains sine terms. Okay, so now I'll give you one example where in this case the periodic function is odd. Let's go to this question. A periodic function ft with period 2 pi is defined within the period t from minus pi to pi by this function, where the ft equals to minus 1 for t start from minus pi to 0 and ft equals to 1 for t starts from 0 to pi. Find its Fourier series expansion. So from this question, how do we know whether this function is even or odd or neither even nor odd? So the best way is to sketch the graph first. So based on this definition of ft, we can now start to sketch the graph like this, where you can see that when ft equals to minus 1, it is defined with the domain of t minus pi to 0. So from minus pi to 0, the ft equals to minus 1. And for t start from 0 to pi, 0 to pi here, the ft equals to 1. And since this function is periodic, we can now repeat this basic function or basic cycle here to the rest of the graph. So based on this graph, as what we learned before, we know that this function is odd. Okay, now what we can do next, after we have identified the FT, whether it is even, odd, or neither even nor odd, then we can use the appropriate formula of FT. In this case, the FT is odd, so we can use the series as in equation 4. Okay, so this is the equation where the FT is only defined with the summation of Bn sine n omega t with the formula of Bn here. What we can see here, the formula for Bn equals to 4 divided by t instead of 2 divided by t with the general formula, and the boundary is always started from 0 and ended at t over 2, whereas in the general formula expansion, in the general formula of Fourier series expansion, the boundary start from any point d to the d plus t. Okay, so that's the difference. Okay, but here the FT, okay, is always multiplied with the sine n omega t dt, where the n is defined from 1, 2, 3, and so on and so forth. So after that, we can identify the t and the t over 2. So the t here, the period is used when we want to define this value. Meanwhile, the t over 2 here is used when we want to define the boundary here. Okay, so once we know that the t equals to 2 pi from this equation, and then the t over 2 equals to pi. Okay, the t equals to 2 pi, then the t over 2 equals to pi. After that, we can find the omega. The omega can be defined with the relationship of 2 pi over t, where here, since the t is 2 pi, then omega equals to 1. After that, we need to identify what is the t and the boundary. So in this case, we only consider the FT for the boundary of 0 to t over 2 only. Okay, so knowing that, okay, we can only define the FT equals to 1, okay, depending on the boundary of 0 to t over 2. In this case, the boundary from 0 to t over 2 is from 0 to pi. So the FT, the corresponding FT is 1. Okay, and then this is the output where we can see that the boundary is from 0 to pi, from here to here. So this is the only FT that we will use for the integral in order to find the Bn. So unlike the general formula of Bn for general Fourier series expansion, we need to identify the Bn based on the boundary from d to d plus t, but it is not the case for this Bn. Alright, so we only consider the Bn for the formula of odd function here based on the boundary from 0 to t over 2 only. Okay, and from there we will get the Bn. After that, we can now plug in all the value of t, the t over 2, the omega into this equation, and we will get like this. Okay, then of course after this, what we need to do is to integrate the value here, okay, to integrate the equation here so that we can get the value of Bn accordingly. After that, then we can get the Fourier series expansion of the FT by replacing the value of Bn, okay, with the summation of Bn with the sine omega t. So that's all for this example. Next, what we need to take care is how to revise the integral, especially when we need to find what is the integral of ft cos n omega t dt, and also what is the integral of ft sin n omega t dt. Of course, the boundary here depends on which formula that we are using. If we are considering the formula of a general Fourier series expansion, then the boundary start from D to D plus T. But if we consider the boundary for the formula of odd or even function, then it must be started from 0 to T over 2. So that's all for now.